Hi everyone, thanks for coming to this session. It is quite late and I would like to introduce Anto, Tomaš and Goran Dumić. And these guys already won the title of the most complex title of session. Custom solution for automating database model synchronization.
Thank you.
So, go on guys.
Thank you. Well, every award is an award. Well, we used to also have the longest title, but this guy beat us by 2 or 3 words. So great session, by the way.
Thanks.
So, welcome to the presentation. I'm Goran. This is my colleague Anto. And if you came to the right track, you'll be hearing us talk about our custom solution for automating database model synchronization. Yes, it's a long title, but we will try to keep it as short as possible. Thank you to the Change Committee for selecting this, because custom implementations are usually not very popular due to the fact that they take up resources and development time, and not all projects can really afford it. So we are thankful to be here. I will start off with a few motivational slides, and then Anto will continue with technical implementation details. Does this work? Yeah. Okay, so if we're talking about motivation, I should probably mention our client's environment, which is complex due to security and data sensitivity. Also, the database contains many vendors' code, and it's really hard to keep track on what's going on when you have a decentralized model changes where anybody can connect at any time and change anything. So our deployments were a bit time-consuming, since you have to manually synchronize source and destination every time. It's a process that goes on and on. We didn't have any history log, so we couldn't tell what we deployed last week, last month, and so on. So our goal was actually implement a custom solution, and we gave ourselves an internal deadline of 2 months for a single junior developer. Anto was a junior developer at the time, he's not a junior anymore. 2 months to implement it. So I will now try to show you how our synchronization process used to look like before all this. It was manual. And it was a common scenario where a business analyst or anybody from your team comes up and says, hey, we have a user demo in like 10 minutes. Could you be so kind to synchronize all the changes since the last month or whatever? And I'm like, okay. And you run your super cool tool, which should be able to do that fast and smooth. And you have, 1,000 steps that you have to go through. For example, picking up source and target connections, picking up object types, 2,000 other options that affect your synchronization. And the process actually starts, and it lasts for about 10 minutes. And the demo has already started. Well, the output of that tool is usually a list of objects that it recognizes to be different. And the number one question when this happens is, what the hell are these objects? Because I have never seen them. They could be some old object that we used to create in some early stage of development. And I don't really want to see these objects every single time. So our vision was actually something else. So what used to be complex, we wanted to simplify. We were going to introduce a silent DDL tracking and a graphical user interface with it, an audit table, which will actually be automatically filled with statements as the developers are executing them. So we exactly know who did it, from which machine, when, and what was the statement. So we have actually centralized something that was not centralized before. It's no longer hard to keep track. When we have centralized something, we can also automate the execution of that set of statements. And we can also build a level up by simply adding additional columns. For example, timestamp when the statement has been executed. and we can make it transparent to the client, to your project team, whatever. So our vision was actually building a resilient automatic system. Resilient meaning that it will try to self-recover from all synchronization errors. For example, if you're executing a create statement, create table, for a table which already exists, it will not fail. We are also using the adaptive metadata injection technology, which dynamically connects your source and target objects. Nothing is hard-coded, so this is the real power behind it. And Anto will now continue. Okay.
Thank you, Goran. I will now continue with the technical part of our implementation. Before we start with the details, we had to set some pre-requirements in order for our implementation to work as planned. The first thing is our development environment is the starting point of our deployment process, which means we won't just throw random data objects into the database without no reason. The first rule was that all temporary objects that are created in our database will be named with a prefix TMP_. That will mean that those objects won't be synchronized or deployed to the test or production environment. Speaking of rules, we had set some norms regarding the code tables. First of them is that all our code tables will have an S_ prefix. That will mean, some code tables can have environment-dependent values. In this example, we can see a code table, a configuration table, which will have a URL to a development project. We will set a negative key to those values so that we know that those URL and other data won't be deployed to the test or production environment, because we don't want a URL which is leading to a development project on our test table. We will also avoid deleting data in our tables. We will accomplish that by adding an active attribute to all our tables. And when we want to delete some data because of some misspelling or error, we will just set the active attribute to 0. And those data won't be shown in our projects and applications. Through the next slides, I will go through the conceptual diagram of our solution. Here we have shown the synchronization between the development database and the test database, but we have parameterized those inputs so that we can manually choose which will be the source database and which will be the target database. So this is how the big picture looks like, and for easier understanding, I will explain it part by part. First of all, we have the audit DDL table. We will fill it with an audit trigger. This trigger will catch all successfully executed queries on our development database. It will look like this. Goran already showed it. And whenever we are starting a synchronization process, when we are doing the DDL synchronization, the synchronization of our objects, we will update this time step so that we know which queries were executed on our target environment. The next step of our synchronization is the DML synchronization, the synchronization of our data in our tables. It will read some information from our list of all tables in our database, which will be updated with the update a lot procedure. The most important information here is the sync with ETL tool flag. This flag will be raised for all the tables that we want to synchronize to our test and production, and by that I mean the data inside of those tables. As we said, all our code tables will have the S_ prefix, and that will mean that the sync with ETL flag will be automatically set to 1, because we want all our code tables synchronized on all our environments. The third step of our synchronization is the privileges synchronization. We will get all the privileges from our source environment and synchronize it to the target. All 3 steps of the deployment process will input some logs in our log tables, and those log tables will be used to create some reports which will be available to the whole development team so that everyone knows when was the last synchronization, what was synchronized, and what will be synchronized. Regarding the technologies and tools we used, because all our projects were on a Oracle database, this custom solution was implemented for our Oracle database. But with minor changes on the meta views, it can easily be implemented on every other database. For the main part of the deployment process, we used an ETL tool called Pentaho, and we also had a tool which was built by Goran, and it is the Deploy Manager tool. This tool will be used when we have a minor set of objects which have to be deployed to the test or production immediately. And for the reports, we use Microsoft SQL Server reporting services. Now it's time for the demo. Let me just find it. So yeah, we prepared a short video. I will have to duplicate the screen. So yeah, it will be played in the VLC player. For our demo, we created a code table called sDeviceType, and this table is created on the development database. We are generating some audit triggers, and the third part of creating new objects in our database is updating the lot table. As we said before, this lot table will have the ETL sync flag, and for this code table with the s_ prefix, it will be automatically set to 1. So that we know in our synchronization later that the data that will be inserted in this table has to be also deployed to the test and production environment. So yeah, in the next steps, we will insert 3 entities in the sDeviceType table. Don't forget to commit. And now our deployment process can start. This is how the implementation looks like in Pentaho. When we start the deployment process, we will get a pop-up window to choose which is the source and which is the target environment. I won't get into the details of every step, but the most important information to know is that in the beginning we are performing some foreign key backups. We are copying the lot table and the audit DDL table to the target, and in this DDL sync step, it will read the queries from the target audit DDL table and execute it one by one on the test environment, because we choose the test environment as our target. In the DML sync, as I mentioned many times before, it will read the lot table and check the sync with ETL flag and sync the data on the tables which has the flag raised. And the last steps of our synchronization is syncing the privileges. When our synchronization process is done, it will send an email to the whole development team so that everyone knows, okay, we had yet another successful synchronization. Before we get into the results of our deployment process, as we said, we had some reports ready. We will show you the Deploy Manager tool. This tool has an intuitive interface. It also reads the data from the audit DDL table, and he caught these queries that we were executing by creating new table, and we can just select the queries that we want to deploy and click sync selected. We also had a query which we want to delete in this Deploy Manager because we already know we added a column on the test environment. So by clicking delete, we will just update the audit DDL timestamp of this query, so our synchronization will ignore this query in further synchronizations. So yeah, that was Deploy Manager, and in the next part we will show you how our reports look like. This is our dashboard, where we can see the date and time of our last synchronization and the number of changes that have been made. We can see that we had 3 successfully executed queries. That was the create device type table, create index, and adding the primary key constraint. Also, we have 1 skipped query. As we said, our job synchronization won't break when it catches queries that can't be executed. He tried to add a column that already existed on the test environment table, and it just logged the error and updated the timestamp. The third report will be the DML report. Here we can see that in the sDevice type table we inserted 3 new rows and the values that we inserted. The final example of our deployment process is to update some values from the code tables. As we said, we want all the data synchronized through all our environments in our code tables. So when we update some values and run the synchronization again, it should figure out that we have made some updates in this table and also make it on the test environment. Here we can see the 3 DDL queries that were successfully executed, the one that was skipped, 3 inserts, and 2 new updates on the sDevice type. When we now click on the report, we can see how it looks like when we update some values. So in the first row, we will have the updated value, and in the second row, we will have the new value which took its place. We updated the active attribute from the entity with the primary key of 2. And for those in the back row, here we updated the description from supercool device 3 to changing device. And with this, we will finish our demo, and I will now give the word to Goran to summarize everything and give some final words.
You have seen the demo. Hope you understood the most part of it. Hopefully, maybe somebody will make use of this on their own projects. Bear in mind that we are doing agile software development, which means we have about 5 or 6 deployments weekly in a peak development period. So this really speeds up things. And also bear in mind that this was Anto's first task, so I remember my first task, it wasn't anything like this. Okay, so this solution is pretty good, but we have already a list of to-dos and wish list that we would like to implement to improve it a bit more. We are thinking about implementing a metadata tag statement that would be executed before executing any DDL statements that you don't want to synchronize. Perhaps it's something that you just want to test on dev. So you execute don't log this next statement, and it really won't be. So Yeah, we could definitely boost performance by adding the parallel threading. Currently, all code tables or business-related tables are synchronized by data. That may not be the optimal process, so we might add only data that actually changed, could be synced. And the last thing, we're really close to implementing this. We have a universal job that we could run at the end of the synchronization process that would once again compare the source and target objects and try to generate a different scripted difference. So this is a tricky part, but for a simple scenarios it really works. So this is a final check that says, yes, you don't have anything to synchronize anymore, or these are the changes you missed somehow. So this concludes our regular part of the presentation. If you have any questions or doubts about this solution, anybody else please.
Hi. Does it work? Yes. Is it possible to roll back all this synchronization if something fails or you change your mind or something?
Well, yes and no. DDL statements cannot be rolled back in theory, but now you have a history log. So at least you know what you executed and in which order, so you can order them back. So if you created something, you can drop it and so on. So currently it doesn't support automatic redo, but quite frankly, in my five years on this project, we have never had this scenario. So basically, if we're not deleting anything, and we also avoid dropping something if it's not really crucial, then undoing is not very necessary, or it is easy to do. There was a question here, yeah?
Yes, you showed us how you handle. Is it work? Okay.
Oh yeah.
You showed us how you handle DDL sync, then data sync, and what about PL/SQL sync? Do you have? Is it not necessary in your project, or you skipped this part?
No, it's a part of the DDL.
Ah, okay.
All the DDL statements, for example, create, package, whatever it is in that step also.
Okay, those statements can be very long. Packages are potentially very long, so you every time when you change a package, you put the whole package source in the...
Yes,
okay.
we insert it into its log.
Okay.
Yeah. So.
And what about data migration? Because when you change something in the model, almost always it's necessary to handle the existing data. For instance, when you add a new column that is not null, you have to fill it. You handle this also through this audit.
So I would say that this table has to be business relevant. We're not talking probably about subscribers table, which has 30 million rows. But if we're talking about code table, then yes, you can actually. We're currently working on that process that even DML statements could be logged into that same audit table, so they can be grouped and executed along the
together with the rest.
Yeah.
Okay, thank you.
No problem. Any other questions? Anybody else? Whoa, nice catch.
First try. On the screen with the tools you used for this synchronization process. You mentioned deployment manager. What's that tool?
That was our custom tool, actually. We deployed in the process. It was designed as an administrative console where you can actually see the pending DDL changes that have to be that are yet to be synchronized. And also it can be used to compare the source and target packages, for example, and it will run the analysis and told you which lines are actually different. So it's something that we implemented to make our lives easier.
Is this tool available online or?
Well, actually, it is. It is.
You can buy it.
No, it's given to the community free. So.
Okay, I'll ask you after the presentation.
Okay, no problem.
What are the technologies behind this tool?
So, Oracle database. We use it because our client uses it.
Do you mean the deployment manager tool?
Yes.
Oh, the deployment manager. It's Visual Basic, and database could be any, but this is Oracle.
And it supports, what databases does it support?
It can be installed on any of the. Yeah.
Any more questions? Okay, so thanks, Anto.
Thank you all.